Imagine this. Electric cars are everywhere. You see Teslas, Hyundais, BMWs, and local brands rolling out sleek EVs. But when people are asked what's holding EVs back, the answers are always the same. Charging takes too long, the batteries don't last, or they're too expensive. But what if the biggest barrier isn't just charging speed or cost? What if the real revolution is happening inside the battery itself, quietly, without flashy headlines, by a company that many people haven't even heard much about? That company is BYD. And they're not just another automaker. They're a battery innovator. Their breakthroughs could change the future of electric mobility, sustainability, and even how we think about energy as a whole. This is the silent revolution you probably haven't noticed, but it's already reshaping the world of EVs. Most people think of Tesla when they hear electric cars. Maybe Volkswagen, Hyundai, or some European luxury brands. But here's the thing. BYD, short for Build Your Dreams, is one of the world's largest producers of rechargeable batteries. They've been around since the 1990s, long before the EV boom. And unlike most car companies that simply buy their batteries from suppliers, BYD actually makes their own. They control almost every stage of battery production, from raw materials to final assembly. That's called vertical integration, and it's a huge advantage. In fact, BYD quietly surpassed Tesla in 2023 in total EV and plug-in hybrid sales. Yes, you heard that right. They sold more vehicles than Tesla. And yet, in the West, they don't always get the same attention. But the real story isn't about sales numbers. It's about how BYD has completely reimagined the battery. At the center of that story is their game-changing innovation, the Blade battery. So what makes this Blade battery so special? At its core, it's built on lithium iron phosphate chemistry, better known as LFP. If you've heard of EV batteries before, you might also know the other big chemistry, nickel manganese cobalt, or NMC. Most high-performance EVs, like Tesla's long-range models, use NMC because it can store more energy in the same space. But that performance comes with serious trade-offs. NMC batteries are expensive. They rely on scarce and problematic metals like cobalt, and they're less stable. BYD's Blade battery flips that logic. Instead of chasing raw energy density at all costs, it focuses on safety, structural strength, and long-term performance. The cells are literally shaped like long, thin blades. This isn't just for looks. It's a brilliant piece of engineering. By making the cells slim and long, BYD can pack them directly into the battery pack without wasting space on bulky modules. That design is known as cell-to-pack integration. The result is more usable energy, less wasted material, and better thermal management. And then there's the famous nail penetration test. Most traditional batteries, when punctured, catch fire or even explode. The Blade battery? It barely heats up. That kind of thermal stability is a massive leap forward for safety. Imagine being in an accident and knowing your car's battery is far less likely to catch fire. That's not just innovation, it's peace of mind. But the story goes deeper. Battery innovation isn't just about performance. It's also about sustainability. And this is where BYD stands out again. Remember that NMC batteries rely heavily on cobalt and nickel. Mining those materials is not only expensive, but also linked to serious environmental and ethical concerns. Cobalt, in particular, is often mined under dangerous and exploitative conditions in parts of Africa. LFP chemistry avoids most of that. It uses iron and phosphate, materials that are abundant and more evenly distributed across the globe. That means less dependence on fragile supply chains and less ethical baggage. And when you zoom out and think about the full battery life cycle, mining, production, use, and recycling, BYD's approach is about minimizing harm at every stage. Because the blade battery lasts so much longer than traditional designs, sometimes well over 1.5 million kilometers in cycle life, it means fewer replacements, less waste, and a step toward a more circular economy. And since BYD controls so much of its production in-house, they have better oversight of sourcing, manufacturing, and even recycling. This isn't just about making better cars. It's about reshaping the entire ecosystem of clean energy storage. Now, let's talk performance, because that's where myths and misconceptions often cloud the truth. Critics of LFP batteries often say they don't have enough range. And yes, a few years ago that was true. LFP batteries lagged behind NMC when it came to energy density. But BYD has closed much of that gap. With their blade design and ongoing R&D, BYD's cars now achieve ranges that are practical and competitive, especially for the way most people actually use their vehicles, in cities and for daily driving. But range isn't everything. Where LFP really shines is longevity. While NMC batteries often start to degrade after a few 100,000 kilometers, LFP can last far longer, sometimes even beyond 1 million kilometers. For the consumer, that means a battery that can outlive the car itself. Imagine buying an EV and never worrying about replacing its battery for the entire life of the vehicle. That's a game changer. Charging is another area where BYD is making strides. Because of their material science and engineering, the blade battery allows for rapid charging that's both safe and efficient. You get strong charging speeds without the same risks of overheating or thermal runaway that other chemistries face. So instead of asking, does it have the longest range in the world? Maybe the real question is, which battery will still perform after 10 years of daily use? And increasingly, the answer points to BYD. So what does all this mean for the future of EVs? First, it means adoption could accelerate much faster than expected. BYD is already producing electric vehicles at price points that are far more affordable than many competitors. And that's critical, especially in emerging markets where affordability and reliability matter most. The blade battery could unlock mass EV adoption in regions where the switch to electric vehicles has been slow. Second, it sends a shockwave through the rest of the industry. When one company sets a new standard for safety, sustainability, and cost, others have to follow. We've already seen Tesla adopt LFP chemistry in some of its cars. And you can bet that more automakers are paying attention. Third, it changes how we think about energy storage beyond cars. The same batteries that power BYD's vehicles can also stabilize power grids, store renewable energy from solar and wind, and bring reliable electricity to communities that need it most. That's a future where clean energy isn't just powering cars, it's powering lives. But here's the bigger picture. Sustainability isn't only about what companies do, It's also about what we choose as consumers. When you buy an EV, you're not just buying a car. You're voting for a particular kind of future. A future where batteries aren't just faster and longer lasting, but also safer, cleaner, and more ethical. So the next time someone says, EVs aren't ready yet, you'll know the truth. Thanks to innovators like BYD, the revolution is already here. It's quiet, it's steady, and it's changing everything from how we drive, to how we source materials, to how we power our world. If this opened your eyes to why battery technology matters as much as the cars themselves, don't forget to hit the like button. It really helps us grow. Share your thoughts in the comments. Do you think BYD's approach will set the global standard, or will other chemistries eventually win out? And if you want to keep learning about the technology reshaping our future, make sure you subscribe, because we have more deep dives coming soon. The electric revolution isn't just about cars, it's about the batteries inside them. And those batteries, BYD might just be building our future.